In this part, we are going to talk about the ownable contract, and you can see the security contract address in the previous part is external, so everyone can call it, and so everyone can change the CryptoKitty address and still break our app. So we do want to have the ability to update address, but we just want the owner can update. To handle this case, we have to make the contract ownable. So there is a library, the Solidity library is open Zeppelin, and you can make the function can be run if you are the owner of the app. So give the contract below a read through. You can also see a few things we haven't learned, and this is the ownable contract that is from Zeppelin, and you can click at here. You can see the program here too, and now you can see it will check whether you are the owner of the contract, and this is the owner of the contract. And at the later part you can see it will require this is owner, so it will check whether who execute this function is the owner of the contract. And we can skip this part, and you will see we have this constructor, which is a optional special functions that has the same name as the contract. It will get execute only one time when the contract is first executed, and the function modifier only owners. And later we will use these only owners to add to the functions, so only the owners can execute these functions. And so the ownable contract basically does the following. When the contract is created, the constructor set the owner to message.sender. So this is the owner of the app. So this is this part, and it add only owner modifier, which can restrict access to certain function to the owners. It allows you to transfer the contract to a new owner. It has the transfer ownership functions, and only owners is such a common requirement for contract that most the app start copy and paste this file and then put that in their contract. So we want to limit the security contract address to only owners. And you can also see these underscore. The underscore, which means it will run the rest of the function if there is no error at this statement. And now we are going to put it to the test, and we've gone ahead and copied the code of the ownable contract into a new file, and this is ownable.sol. Let's go ahead and make the ZombieFactory. Inherit from it, so we have to add is ownable. So the first one is we have to modify the code to import the content of ownable.sol. If you don't remember how to do this, take a look on the zombiefeeding.sol. So now we copy this and then write at here import, and modify the ZombieFactory contract to inherit from ownable. Again, you can take a look at the zombie feeding if you don't remember how this is done. So we already inherit from the ownable, so now we can check the answer. So we can go to next chapter.